Hello, good morning, all of you. I think all of you are fine. Okay. In the last class, we discussed about the set, definition of the set, type of sets, and in that type of sets, we discussed the subsets. Is it or not? Okay. So we'll start today. We'll start with that subsets. What is subset? Recall the subset. What is subset? That subsets. If x and y two sets, x and y two sets, okay, x is called subset of y if each and every element of x is an element of y, and it is written as x is subset of y. This is a symbol of subset. So what will say here? X is subset. We read in this as subset of y. X is subset of y. Okay. That means mathematically what we can say? Elements which belongs to x, that elements also belongs to y. If we take x, that is a belongs to x, it implies that a belongs to y. A, we are supposing that a is an element, that is why it is in x, and it implies that we are getting that a is also in y. Then x is subset of y. Okay? And if x is not subset of y, then what will write? X is subset y is not, just to cross it, slash, the help of slash will explain that it is not a subset of y. Here, if x is subset of y, that is x is subset of y, then y is called superset of x. That is what we like, y is superset of x. This symbol is superset. This is used for superset. Is it clear for subset? Any elements belongs to x is set. Any elements a which belongs to the set x, and that also belongs to y. In that case, what we can say, x is the subset of y. Okay, clear? Now some points in subset. We have to note, keep some points in our minds. What are the notes here? First one is what? Phi. What is phi? And this set. Phi is subset of all sets. Whatever in this word, whatever the sets we take, phi is the first and foremost subset of the set. Okay? The set itself is a subset. The set itself is a subset. That is, A is a subset of A, B is a subset of B, C is a subset of C. Next, what you can say? If A is subset of B and B is subset of A, then A is equal to B. Or mathematically, what you can write? A is subset of B and B is subset of A. It implies this conditional if and then. So mathematically, by conditional, we can use this is by conditional. A is equal to B. Both sides are true. That means if A belongs to A subset of B and B subset of A, implies A is equal to B. Or we can say if the sets are equal, then A subset of B and B subset of A. Now how can you find out the number of subsets? Number of subsets. Let's see. Number of subsets. Suppose A is a subset with number of elements is 3. What is the number of elements? 3. So subsets are, what are the subsets? First subset is 5, empty set. Next, if we take 1 1 elements, that is 1 2, then 3. Next is 2 2 elements, 1 2 1 3, then 2 3. Anything more? No. And the last one is the set itself, that is 1 2 3. The total number is how much? 1 2 3 4 5 6 7 8. 8 number is 8. If A is equal to A comma B, the subsets are, what are the subsets? 5. Subsets are 5, then A, then B, then A comma B. What is the total number? 4. If A is a subset, the single element, then subsets are what? 5 and 1. That is what? 2. A is empty set, then subsets are, what are the subsets? This is 1. Subsets are 1 only. That is what? That is 5. Subsets are 5. Okay. Now see, if number of elements, if you say number of elements and number of subsets, how can you make the relation? If 0, how many subsets? 1, 1, how many subsets? 2, 2, how many subsets? 4, 4, how many 3, how many subsets? You are getting 8, 8 subsets. Now can you make the relations between these numbers and any common characteristics? This can be, how many numbers of elements? 3. So what do you get? 2 to the power 3. 2, so 2 is square. 1, so 2 to the power 1. 0, 2 to the power 0. So if number of elements we get, number of elements of sets we get, we can easily find out the number of subsets. If number of elements is equal to n, so note 4, what you can say? Here note we can say number of subsets. Note, if A has n elements, then number of subsets of A is equal to 2 to the power n. So if I say a set has 4 elements, total with the number of subsets 2 to the power 4, 5 elements 2 to the power 5, 6 elements 2 to the power 6. So in this way you can confirm the number of subsets of a set. Okay, clear about the definition of the subsets and points and the number of subsets, how to find out the number of subsets and how to find out the subsets. Next, in subsets of set of real numbers, subsets of sets of set of real numbers, subsets of set of real numbers. In class 10 we got this concept of real numbers. What is the concept we have of real numbers? The real numbers, this is divided into what? Rational, that is what we can write Q. This is QC, rational. Then rational is integers, positive integers, negative integers. Then 0, positive and negative, positive integers with 0 is whole number, positive integers on serve is natural number. Okay, more numbers are there, just taking this concept. Now what you can say, if we say n is what? Natural number start from 1, so 1 2 3 dot. Whole numbers start from 0 1 2 3. Now see, integers I is start from what? This -2, -1, 0 1 2. If we see here, n is a subset of what? All the elements of n belongs to W, so n, we can say n is a subset of W. Similarly, W is, whole numbers is subset of integers. Integers is subset of rational numbers and rational numbers is subset of real numbers. So what we can say, n is subset of whole numbers, natural numbers subset of whole numbers subset of integers subset of Q, and Q is the subset of real numbers. Okay, this is the subsets of set of real numbers, subset of sets of real numbers. And irrational numbers is also subset of real numbers, but these are natural numbers, whole numbers, integers, and rational numbers are not subset of irrational numbers. Be careful. Okay? Okay. Let's see the next. What? Number line. Real number line. If we draw a number line, real or number line, that is positive, this is negative. Okay. Now in between this, if we take two real numbers, a comma b belongs to R, such that a is less than b. How can we plot these 2 points? A is less than b. Which is greater, that will be positive side, and which is smaller, that will be in the negative side. So this is a, this is b. Okay. Now if we take x as a real number, x is a real number which lies in between a and b, how many ways we can represent that x? See, one thing is, this is x may be in between a and b. This way also you can say x, that real number lies in between a and b. Now how can you write mathematically, that is a is less than x less than b, that x not included b or a. It is greater than a, less than b, near to b, near to a, not a and not b. Okay, that is this part, the only this must part, the only this must part, if we say this must part. This is one way. Another way, this is a, this is b. Now we can include it both in a and b. This is x included, that means both the points a and b we can include it. This is the a and b. So here what we can write, a included, x value x is included with a, so x less or equal to a, less or equal to b. Next way, next type, what is the next type? This is the positive, this is the negative. Not included a, but included b. We can include b. This is x, so x is not included, but x is included b. This is one way. Another one is what? This is positive, this is negative. This point is, this is a, this point is b. So here what you can say? Included a but not included b. A is less or equal to x less than b. These are 4 types of. We are taking this one interval in between a and b in the real line. Okay, that is called interval. This is known as open interval, and this will write what open. The endpoints, both the endpoints are written within the parenthesis separated by comma. This open interval, and this is included both a and b. This is written within the third brackets, within the third brackets, and separated by comma. This is called closed interval. This is what, with the help of this, what you can say, first one is open, second one is closed. So this is a, this is b. So what you can say, semi open, and this is what, first one is closed, second one is open, semi closed. Okay, these are the 4 types of intervals. So what you can say, the first open interval, closed interval, semi open interval, and semi closed interval. Now how can you write these open intervals in the set builder form? This is the open interval. Suppose x belongs to a comma b, then how do you write? This means what? Implies what I can write in the set builder form. What you can write? X such that x is less than a, less than b. If I say x belongs to closed interval a comma b, then what do you write? X such that value of x lies between whom? A and B, included both A and B. Okay, so A is less or equal to X, less or equal to B. X, this is 1, 2, 3 number. X belongs to, first one is open, semi open, then X such that A is less than X, less or equal to B. A is less than X, less or equal to B. And fourth one is X belongs to, first one is closed, second one is open. So what we can write? X such that A is less or equal to X, less than B. This is the four types of the intervals. First one is open interval, second one is closed interval, semi-open interval, semi-closed interval. Okay. Now see one example. If X is a value which lies between -2, 3. If in this way we will write, how can I express this in set builder form? So what will write? X such that -2. This is -2. First one is closed, less or equal to X, less than 3. Okay. This is the way to write. If I write X belongs to -3, -1, what will I write? X such that -3 less than X less than -1. Clear? So this is the way to express in the interval as well as the what? Set builder form. If it is given in the set builder form, we can write in the interval. If it is given in the interval, we can express in terms of set builder form. Okay, clear? Now next one is power set. What is power set? Power set. The set of all subsets of a set A is called the power set of A, and it is denoted by what? PA. Power set is denoted by P. If A is a set, then power set of A is there. As for example, see, if A is what? A comma B. What are the subsets? All subsets. We have to find out all subsets. Subsets are all subsets. How many elements is 2? So how many subsets will get? 4 subsets. So what are the subsets? 5. This is A. This is B. And this is A comma B. Now sets of all subsets. So PA. Order like PA. Set. These are the elements of the new set. This is one set. PA. This power set is a set. So its elements are the subsets of the set. That is 5. This is A. This is B. This is A comma B. So this is the power set of set A. Okay. If I take the example. See, A is equal to -1, 1. What are the power sets of A? PA. What will I write? There is 5, then -1, then 1, then what? -1, 1. Okay? This is the power set. This is the definition of the power set. Now see, example 1 example. In this, here, what we can say? This -1 is belongs to PA. -1 is belongs to PA. This is set -1 is not subset of PA. -1 is not a subset of PA, but -1 belongs to PA. Okay, be careful here. These are the elements of PA. These are the elements, one elements are there. Okay, this is again a set. But -1 is the subset of what? A. -1 is a subset of A. 1 is a subset of, if we write 1, 1 is also subset of A. 1 is just simple if we write 1, 1 belongs to it. 1 belongs to it. 1 is not belongs to P. 1 is belongs to A. Okay, so this is the concept of the power set. This is the concept of power set. So we learned here what subsets of set of real numbers, intervals. How many types of intervals? 4 types of intervals. One is open interval, one is closed interval, one is semi-closed, one is semi-open. Okay, then power set. Clear? So in the next class we'll discuss more. We'll come with more things, that is our operations of sets. Also with the help of the Venn diagrams, we'll discuss about the Venn diagrams also. If any doubt, you can ask and you can send a message in the comment box. Thank you. Have a nice day.